Okay, I just went to Home Depot and got some parts. Want to build a high voltage variable capacitor, and I got the idea from something online. This is going to be a 3-plate capacitor, which I think has some advantages. I think you can get better high voltage isolation. But let's look what we got here. I got some plastic sheets that are, what are they? 11 by 14. Okay, so 11 by 14 sheets by, they're very thin, like, what's that, a 1/16 of an inch or something? 1.3 millimeters, 27.9 by 35.6 by 1.3 millimeters, or it says 0.05 inches. Okay, so they're very thin, and of course the thickness is going to determine how high a voltage you can hold off, because it's going to be our insulator. I'm going to use plexiglass. It's probably not the best for high frequencies, but we'll see. I'm not going to go too high a frequency. I just wanted some high capacitance variable capacitors, and this is going to fit the job with high voltage isolation, because we're going to be doing some interesting experiments with high voltage and possibly anti-gravity. Okay, so I'm not sure if I'm going to use the threaded rod. That's in case I want to put multiple plates in line, but I think I'm just going to start out with one plate. So we'll set that one aside for now. And I need an insulator to hold this together. And actually, epoxy can be a very good high voltage insulator. I knew some companies that I was working with, and they built Marx generators and other things, directed energy weapons, and they would use epoxy as their high voltage insulator because it's supposed to be very good. Okay. Yeah, I don't know what the loss tangent is on these. My initial thought was to go with glass. I mean, you could use glass too, but if I want to put a bunch of plates and drill a hole in the middle, it's a lot harder to drill a hole through glass. Glass is harder to work with. It shatters and it's not easy to cut or drill through. Okay. And here I got some 6" by 50 feet aluminum flashing, and I think that these insulators are wide enough that I can get 2 of these strips along here like so, and if not, I'll just have it overhang. But I want to have good high voltage insulation between these because we want to build a very high voltage variable capacitor, so we can do some interesting experiments with that. And so there we go, there's our parts, and I guess we'll get to work on this project. It should be interesting. Okay. Okay, so I think the first thing I'm going to do is we'll measure out a couple plates and just make them a little bit longer than this, and maybe I'll cut them down so that they don't have arcing between them. Let's well, okay, just cut this, I guess. Got some nice scissors here. Oops. Okay. Okay, there we go. Okay, so here's our aluminum flashing. And let's just measure out a couple pieces. Looks like it's kind of bent there. Maybe we can press that down. So I'm going to make it a little bit longer so I can put some tabs on it or something. Maybe I'll get a straight edge and make it straight across. Okay, I think this will make a good straight edge here. Let me just mark it and then we'll cut it, okay? Okay, so I just put it in between these plates. I'll use these plastic plates as a straight edge. And we'll have overhang about 1 inch up there. And okay, make sure it's straight along this edge. Okay, let's mark that one off. Up. Oh, come on. Okay. That's pretty straight, I guess. And where my scissors go now? Oh, there they are. Let's cut this. Okay. So let's take this and we'll mark a second one. Along there, like so. Oh, this aluminum thing's unrolling. Oh gosh, it's becoming unruly. Okay. And we'll cut that one off. Okay, I might want to tape this back up so it doesn't unspool all the way. And let's test fit these plates into the dielectric here. Okay. Okay, so I'm just trying to lay out these. I wish these were actually a different size, but this is what Home Depot had a lot of. And this is what Home Depot had for size, so I'm going to try to make this work. And I think I'll just do it so positive will come out one side and negative will come out the other, and I'll do an insulating glue in between the two to hold off the high voltage, and then we'll put the second plate on top. And I think maybe I'll cut some electrodes. It would be more ideal if these were square, or because there's going to be a little bit of wasted space, but we'll try it out. It should work for high voltage, and oops, should be cheap to build, so we'll give it a shot and see how it works, okay? Okay, I think I'm just going to do some quick tests, and instead of gluing it down, I'm going to tape it down. Let me fix the tape. Okay, so we got some packing tape here, and I've kind of laid these out about where I want them to be. Let's get some tape out here. And we'll try taping these down. Okay. And get some more tape for that side. Leaving a little bit of edge. Let's take a look at this in a second. So I'm keeping the electrodes in from the edge a little bit so they can't arc around the edge. And I'm going to take another piece, sandwich it between them like so. Okay. And that's going to be our stators of our capacitor. And then I'll take this guy here. Okay. And this will be our rotor. And I'll try to tape down our pieces here, leaving them a little bit in from the edge, like so. Let's move the bottom one so we can see this better. Okay. I'll position these in from the center a little bit, about a ½ inch between the two. And we'll tape these guys down also. And then we'll just do some quick tests with our capacitor meter to see what our capacitance is. Let's see how much we can vary the capacitance by creating such a capacitor. Okay, get that one aligned. I'm keeping this one also a little bit away from the edge, so I'm concerned about it arcing. Some of the electrode is not going to be protected as this thing rotates. Okay. And actually I was thinking I might be able to get away with just taping this thing and not even having to glue it. We'll see. Get this positioned. Okay. Gotta leave some room in the middle so we can put some kind of screw in there to pivot it. Okay. So we have two plates here, one on the top and the bottom of these guys. And I think I might leave this plate in the middle so it has higher dielectric in it. Plus when it rotates it's going to go over top of these electrodes like that, so I want insulation between these because I don't want it to arc across. Okay. And so the idea is you can rotate this guy like this or like that and you'll get different capacitances, and it should be insulated to high voltage. Okay, so let's get our capacitor meter and we'll test it out. Okay. Okay, so let's measure the capacitance, and turn this guy on, and we'll put him in capacitive mode, and it looks like it is about 8.8 picofarads in the low capacitance setting, and so we in principle will be able to rotate this like so into the high capacitance setting. Oh, let me move this electrode so it's not in the way. Okay. There. Okay. And that's saying about 11, 12, 13 picofarads. Let me just remove that. Okay, so 8 picofarads without that in place, which is about what we had before. And well, if we push it down tightly, it's about 16 picofarads. Oh, very interesting, huh? Okay, so it's not as big of a difference as I was hoping for. Oh, let me put this electrode back on. Okay, so about 15 in the high position and 8 in the low. So I was hoping for a bigger difference in that. Okay. Okay. Okay, I wonder if I flip it over so that the metal part is closer, less dielectric. Okay. Oh, I think it's cheating. It's touching the metal, so it doesn't count. Oh. Okay. That's interesting. Now I'm getting about 40 picofarads. Okay, so these are, make sure these electrodes are on well. Okay, so in the low setting, I'm getting about, again, 9 picofarads. In the high capacitance setting, okay, maybe I didn't have something hooked up right. Now it's saying about 43. Okay. So 43 there. It's a little bit better. And that's what, 14. I wonder what happens if I just disconnect it. Okay, that's about 8. So maybe the lead wasn't making good connection before. Okay, so we've got 6 picofarads. And rotated like that. Make sure these are making good connection. Okay. Okay, so maybe it's just not making good connection through the aluminum oxide layer. Okay, because when I do that, it's about 40 some picofarads. Okay, so 40 picofarads. I could do some calculations and see if that's what I think it should be. Okay. And we'll go back again to the low setting, which is about 9 again. Let me just disconnect it, because that could be just residual capacitance of the meter. Yeah. Okay, so the meter has about that much capacitance. So I think we might be getting a pretty good change in capacitance between the low setting and the high setting. Yeah, see, that's about 38, so that's a significant increase in capacitance. That's about 40, 42. Okay, so this might be usable. Okay, so maybe we'll drill a hole through the center here and test her out again. Okay, so let's see, I got some nylon screws because I didn't want to, if you put some metal ones in there, it's going to produce a path to arc process possibly. And so let's just do this. I'm going to, I did peel off the sticky tape stuff that was on these boards, but I'm going to stick some tape back down on it. Let me clear this piece off, because when you're machining on these plexiglass things, it's probably better to have the reason why they put that tape on there is so these are very easy to shatter. They're very brittle, I guess you could say, and that putting some tape on it will help it be less likely to shatter. Let me mark out the center here. That's about 12 inches. So I'll put a dot kind of in the center. Okay. And I have a piece of wood here, so we'll try drilling over the wood. And in order to make sure that we don't splinter it, I'm going to start out with a smaller drill, and then drill a pilot hole maybe. Actually, maybe I'll even start with a smaller drill yet. Get a pilot hole through it, and then we can work our way up to a larger size until we get a hole big enough for our quarter 20 screw, my nylon quarter 20 screw. Let me just measure this with my fingers. Okay, it looks pretty close to the center. I'll have to drill a hole in the rotor and the stator, and I guess let's get started. Okay. I'll put a little bit bigger drill in and drill it out. Okay. Okay, so I ended up drilling. I didn't find my quarter-inch drill because someone Won't say who. Couldn't be me though. Didn't put it back in the drill case here. But, so it's missing. And so I did a 64th larger. And here's our 1/4 inch screw. And it will go through here. Of course we're going to put it through this way, through the top. So we got that one drilled, the rotor, and we will work on the stator next. That one's going to have 2 pieces of plexiglass, so I'm going to put tape on those and drill those out with a series of screws, getting larger, hopefully not to split it out. And then we'll put this thing together, and we should have a high voltage tunable capacitor working. Okay? Okay, so it did look like one of the plexiglass did develop a crack right here. But I guess I'm just using one side as a backer plate, so let me put that one on the bottom, because we want high dielectric strength between this plate and the plate that's going to be above it and that plate, and so there's no cracks around here. And that's part of the reason why I wanted to use nylon screws instead of metal screws, because that could provide a conduction path to a place that we don't want it to at high voltage. And oh yeah, here I got some nylon nuts too, just in case. I mean, the whole thing was cheap, I think, less than a couple dollars. Okay, so there's our stator. Here's our rotor. We'll thread that onto our screw and put our nut on it. Okay. And let's test this guy out then. Okay. So there we go. High voltage variable capacitor. Of course, you might not want to touch this aluminum plate when you're running high voltage on it. You might get a shock. So I'll touch on the corners maybe. Yeah, maybe I should make some kind of lever or something so you can turn it with. I do have some distance here. You can see that. So you could just turn it at the corner. You're going to want to be careful when you're running this at high voltage if you're trying to tune it at high voltage, because that could be dangerous. Maybe you want to turn off the high voltage and tune it and then put it back. Okay, so I guess it's time for us to test this thing now. Should be interesting. Okay. Okay, so I wanted to do some calculations to make sure what kind of voltage we can stick on this without wrecking it. And so I looked up the dielectric constant of acrylic or plexiglass. Okay, and it's saying or not the dielectric strength, I'm sorry. And it's saying it's about 17 to 30 kV per millimeter, and the plexiglass is several millimeters thick, and I was only planning to put about 15 kV on there, so as long as it's at least a millimeter thick, I think that we should be able to put that much voltage on without wrecking it. Probably even higher, right? Okay, so let's do some high voltage testing of it. Okay, so here we have an induction coil. Let's take a look on it. And a high voltage power supply and a spark gap of sorts hooked up to our variable capacitor. And I have it set at the minimum condition. And I let it run for a little bit. Here we go. And actually I took a waveform. It's saying about 72 kilohertz, but let's just try that. Take some more. I don't think it's getting a good measure of the frequency, because let's just do this. You can kind of see how big the waveform is. Okay, and we'll take a look at that waveform. Let me turn this off because I don't want to burn out my power supply. And we will try adjusting the capacitor. So that's about 1 division per half cycle, a little bit less. Let's see if that changes when we turn this to full throttle. I don't think it's having a good time measuring this algorithm doesn't seem to measure non-sinusoidal waveforms that well. Okay, so that's what that one looks like. Now let's see if the frequency is lower now. Okay, the waveform definitely seems different. It has a different type of discharge. It's definitely got more capacitance. Okay. Let's say at 55 kilohertz, although I'm not believing that. Maybe I'll see if I can get this scope tuned in a little bit better so it's triggering in a different spot. Okay. Well, okay, so here it looks like it's about 100 kilohertz. I'm saturating the signal by getting it close like that. And we'll try tuning the capacitor and see if it looks like a different frequency. Okay. Okay, so that should be in full capacitance now. It definitely makes a different type of sound, and it's reading closer to 90 kilohertz. You can see that down there. I definitely think it's tuning the frequency. It definitely has a lot higher capacitance. Okay. And so between 90 kilohertz here, and we'll bring it back to a low capacitance setting. Okay, remember the coil is going to have some capacitance too, so this is just going to add a little bit extra capacitance. Okay. See if we can get this back down there again. Okay, that's about 97. Again, it's not a good uniform waveform. Okay, there, 100 kilohertz. Oh, there we go. So anyway, but it's definitely holding off. We're putting about, okay, there. About probably 15 kV using, I'll talk about some of these things in my other videos. This is the Chinese high voltage power supply, and I showed how to make this using using a computer power supply, and I showed how to make this high voltage resistor that I'm using to limit the power into this device so it doesn't burn out, on another video also. So those are separate videos if you're interested in that. And there's just a Tesla coil that I wound, a transformer, secondary transformer on the output, which I'm not using, and some variable spark gaps. And anyway, I believe that this capacitor is definitely a success. We can, looks like we can tune the capacitance, and it holds off high voltage. We tested it up to probably about 15 kV. I showed in one of my videos where I tested these Chinese power supplies. It claimed to be 400 kV. 400 kV. No way that's 400 kV, but I did test it up to 15 kV. And so that's probably about what we're sticking on this capacitor. And anyway, hope this helps your mad science experiments. This is Dr. Janes, and thanks for watching.